at a local university, GPAs were compared for men and women to see if women have a higher GPA. 45 men were surveyed, and the average GPA for the men was 2.07, standard deviation 0.36. 40 women were surveyed. Average GPA for these women was 2.41, a little higher, with standard deviation 0.89. Give a 99.9% confidence interval for the true average difference in GPAs of men versus men minus women. Okay, men minus women. Okay, yeah. Okay, yeah. So so this is men, and men. What was men? Men was I guess this is mu1 minus mu2. Men will be mu1, men will be mu1, women will be mu2, I guess. Men are listed first there. Okay, men minus women, 99.9% confidence interval. Okay, let's go to the notes. So this is going to be again, here I can just go to the notes here for us. Yeah, ooh, we're past it. There it is. Yeah, so notice, again, this is, we don't have proportions. We have two independent means again. Two separate groups, we have averages, but we're going to use two sample t interval because this is a confidence interval, not a hypothesis test. Does that make sense from the notes? So we're going to use two sample t interval. Two sample t interval. So we come on down and we do that. And so two sample t, oops, getting kind of scribbly there. Two sample t interval. So if you go to your calculator, and that's because these are averages, right? The average and the average, it's not proportions, it's averages. So we go over to two sample t, and so we got to go all the way down. That one's way down. It's like a 0 for me. It's way down on, it's like the 10th one down below 9. We call it 0. Two sample t interval. And then do we have data? No, we don't have any data here, do we? So we're going to choose stats and hit enter. And then it gives you the stuff. It says, okay, what's x1 bar? And s sub x1 and n1, and then it asks you for x2 bar and s sub x2 and n2. So that's all these numbers, right? This is x1 bar here. This is x2. I'll move it down. This is x2 bar. This is s sub x1, s sub x2. This is n1. This is n2. Okay, so we put those numbers in there. And x2 bar is 2.41, s sub x2, 0.89, 40. All right. 0.07, 0.37. And then the confidence level is 99.9, so that's 0.999. Right, because you always move the decimal over two places. Pooled is always no. Pooled is always no. And then we calculate. Okay, so here's what I got. Yeah, this one's tricky. So I got negative 0.8664, comma, 0.18638. So there's the numbers I got from my example, but notice we have to turn it into kind of a different format. And I know that can be tricky. So let's figure out how we put it in that format. How do we actually do that? Well, if you think about it, let me come on down here a little bit. I'm going to go back to the number line kind of logic. We're saying that our confidence interval goes from negative 0.8. Oh, we went to round to two places. So let's make it negative 0.87, right? Round to two places. And then two places, 0.19, right? So negative 0.87 to 0.19. So rounded to two places. So I'll make this negative 0.87. And this is over here, positive 0.19. So we're saying that's our confidence interval. We are 99.9% confident that the difference between the men and the women, right? We're taking mu1 minus mu2, men minus women, that the difference between the men's average and the women's average is somewhere between negative 0.87 and positive 0.19. We're 99.9% confident that and we mean the true, right? Because this is just 45 men we surveyed and 40 women, but we're trying to figure out what might be the true difference for all men in the world that are going to university and all women, right? That's what we're always doing in statistics, is we're taking a small group, a sample, to figure out something that might be true, what is true for the whole world population. That's always our goal, right? In statistics. Use a small sample to figure out something that's true about the whole world. So we're wondering, for the whole world, if we could take every man going to university in the world and every woman going to university in the world, and in which we can't, right? It's just too much data. We can't get all that. But if we somehow could, and find the real average, is there really truly a difference between men and women going to university for the whole world? If you take all men minus all women, what would you get? Well, we are 99.9% confident. We're very sure that that true difference would be somewhere between negative 0.87 and positive 0.19. That's what we're saying. Okay, well, what does that mean? Well, right here, they want us to express it in a different format. What format? What do they want? They want the middle, or average, and the error amount. That's a different way of saying the same thing. So we've got to find the middle. What's the middle of our interval? It's the average. So you average the numbers. So you just take the negative 0.87 plus 0.19, and you divide by 2, which means you hit equals, and you divide by 2 and hit equals or enter again. So you find the middle, the average of the two numbers. So negative 0.87 plus 0.19 equals, divide by 2 equals, I'm getting negative 0.34. So that's the middle of that interval. You see how, you know how to find the middle of two things. You average them, right? You add them and divide by 2. So I added the two numbers, hit equals, and divided by 2, and I got negative 0.34. So that means that's the middle of the interval. That's right in the middle between negative 0.87 and positive 0.19 is negative 0.34. So that's what goes right here, negative 0.34. That's the middle of the interval. And then the error amount is the amount you go forward and backwards. In other words, we're saying we think the middle of the interval, we're 99.9% confident that the difference between men and women is negative 0.34, give or take a certain error amount. And how much error amount is that? Well, that's what we need right here, right? The error amount, give or to see the plus or the minus, this plus minus thing, that's give or take, right? This is the positive error and this is the negative error, is what we're saying. We're saying go forward or backward. Let me see if I can write that better. There we go. Forward or backward a certain amount. Oops. So how do we figure that out? What is that exactly? Well, to find the error amount, you just take the right edge, or just take the middle. How about we just take that number in the middle? Yeah, let's take that number in the middle. middle minus the left edge. Right? You want to know how far back this goes. Just take the middle and subtract the left edge. You'll get how far back it goes. So what's the middle? Well, the middle's right here, negative 0.34. Subtract, and what's the left edge? Negative 0.87. Right? So if you want to find out how wide this section is, this air section, you just take the middle, subtract the left edge, or you could have taken the right edge, subtract the middle. It doesn't matter. Just find out how wide it is. Now, you probably know from your earlier math classes, double negative, it's going to actually add, isn't it? Right? We had the one negative from the subtraction and the other negative because the left edge number was negative. So it's going to be plus 0.87. So negative 0.34 plus 0.87, I'm getting 0.53. So there it is. Bring it on back. Okay, so there's that part of the answer. So what we're saying then is that we're 99.9% confident that the true average difference, men minus women, is negative 0.34. That's the middle of the interval. Give or take an error amount, because we're not 100% sure that's exactly going to be the true difference between all men and women in the world. We know there could be an error in our estimate. This is what they always do when they give confidence intervals. They give the middle, and then they give or take error amount. So we're saying that we're 99.9% confident that the middle is negative 0.34. Give or take 0.53. So the middle is negative 0.34, but you could subtract or add positive 0.53. Whoop, that's this is positive 0.53, and this is a minus 0.53 going that way from the middle of 0.34. That's what we're saying. So we're saying we're 99.9% confident that the true difference between all men and women in the world, their GPAs at university, is negative 0.34, meaning the women are a little higher, right? Because if you subtract two things and you get a negative answer, you're saying the second number is bigger. That's how you subtract two things and get negative, right? The second number is bigger. So we're saying we think the women are a little higher by 0.34 on their GPA, but we know there can be some error in our estimate, give or take an error amount of 0.53. Okay, which is the same thing as saying this interval between negative 0.87 and positive 0.19. Now, what does that mean real life down here? According to your confidence interval, with 99.9% confidence, the mean GAP for men is between 0.19 and 0.87 higher. Is that what we're saying? We think the min is higher? No, that's not what we're saying. Are we saying the min is lower, 0.19 and 0.87, those are our numbers, lower than the GPA for women, is that right? Or at 99.9%, our data is inconclusive with regard to whether men GPA or women GPA is higher? Well, it's this one. It's inconclusive. Why? Because it could be negative and it could be positive. Right? You see how that's inconclusive? What am I talking about? Well, we're saying that the interval, let me come on down here and draw the interval for us again. So think about what that interval means. So that means between negative 0.87 and positive 0.19. So in other words, and remember what this is, it's right here. This is men minus women. So men minus women is somewhere between negative 0.87 and positive 0.19, which means it could be 0, right? It could be a negative answer or it could be a positive answer because it goes from negative territory to positive, which means we don't know, right? If you subtract two numbers, so that's the thing. If this is really confusing for you, what you need to be a little more clear on is what it means when you subtract two numbers and you get a negative answer. If you subtract these two and you get a negative answer, that means the second number is bigger, right? That's the only way to subtract two numbers and get a negative answer. Like if I go 7 minus 9, I get -2 because the second number is bigger, right? So if I subtract men and women and get negative, that means the second number is bigger. But, and I could get a negative answer. That's a possibility. We're saying the answer could go anywhere from negative 0.87 to positive 0.19. But if I subtract the two numbers, and I get a positive answer, what does that mean? How do you subtract two? Well, that means the first number is bigger, right? If you get a positive subtraction, the first number is bigger. That's the only way to subtract two numbers and get a positive answer. That would mean the first one would be bigger. And that could be because we could have a positive answer. Remember, again, the answer could go anywhere from negative 0.87 to positive 0.19. So it could be positive. If it's positive, then the men have a higher GPA. All the men in the world have a higher GPA. If the answer is negative, then the women have a higher because the second number is bigger. The fact is it could be either way. We're not sure because the answer could be negative, which means the women have a higher GPA, or the answer could be positive, which means the men have a higher GPA. We just don't know. All we know is the answer is somewhere between negative and positive, so it could be either one. That's why we say it's inconclusive. We don't know which one is higher. Does that make sense? Now, if the answer had come out only negative, right? If our, oops, go back here. If our confidence interval was only negative, like, I don't know, -3 to -1 or something, only negative numbers. Well, think about what that means. Then it's going from -3 to -1, zeros over here, right? You're saying it's got to be -3, -1. What does that mean about the two numbers? If you take men minus women and you get a negative answer, how do you subtract two numbers and get negative? That'd be like 7 minus 9, right? So that means the second number is bigger. That's the only way to subtract two numbers and get negative. That would mean the women GPA is higher. That's what that would mean. So if we had a confidence interval that was only negative, that would mean for sure the women, the second number, would be higher, wouldn't it? Or, let me give you another what if. What if we had a confidence interval that came out sorry, I'm not being very clear down here. If we got only positive, like +2 to +6 or whatever, think about what that would mean in the real world. If I said, yeah, my interval only goes from +2 to +6, the zero's somewhere over here. So if we're in here, then it's only positive, right? And what does that mean about two numbers? If you subtract men minus women and you get a positive answer, how do you subtract two numbers and get a positive answer? The first number has to be bigger, doesn't it? Higher. That's the only way to subtract two numbers and get a positive answer. So that would mean the men would have a higher. So if we had gotten an answer that only had a confidence interval that was only positive, we would have said, oh, that tells us the men have got to be higher. And if we got a confidence interval that was only negative, then we said, oh, the women's got to be higher because that's the only way to get negative is when you subtract two things, the second number's higher. But if we happen to get a confidence interval, right? What was our confidence interval? Back up here. It's right here. It had negative and positive. So ours is inconclusive.